So I'm just going to try and impart some of that information to you. So the first question that I've chosen is find the derivative. It's actually given, so there isn't even an instruction, it's just given to solve. And we have a d by dx. There's actually a dx, so this is the first notation that I'm going to use here. And we have x cubed. We have the root of x cubed on the top, the root of x cubed. And we then have a plus 3x to the power of 1 over 3. And this is all over 2 root x. Okay, the first thing to notice is that when this funny big D, let's call it big D notation, gets used, it's quite important that the equal sign on each step gets put on the outside. So while you're changing what this thing looks like, so before you can differentiate, make it into a differentiable form. And while you're busy doing that, you need to put equals and then your d of x sign over there. That's the first thing that I'd like to say. Right. So I'm still writing d of x because at the moment, all I'm going to do is simplify what's inside this bracket over here. So we don't like working with roots. Okay. So these are the things to change. So we're going to say here, change roots to exponents. That's the first thing I think is important, right? So I'm not so happy about this cube root sign over here. I'm going to change it to an exponent, and I'll keep writing this d of x over here, and I'll get x to the power of, let's just make that a little bit lower down so we can see what's happening here, and that's going to be x to the power of 3 over 2. Why is it 3 over 2? Remember, a square root of a is equal to a to the half. Because I already have a cube there, it means that in actual fact I have x to the power of 3 all to the power of a half, and together that will jointly become x to the power of 3 over 2. And then I have this plus. I don't need to change the second term over here because it's already in a differentiable form. And let's change the bottom and I get 2. Over here I have another third, so the first thing I'm going to do is eliminate the third by writing it as a fraction, and that's 2x to the power of a half. And then I'm going to close this bracket over here. Right, that's the first step. The next step we notice is that if you have more than one term on top, okay, so let's maybe take a different color here, and if you have more than one term, a single denominator, and multiple terms on the numerator, multiple terms on numerator, which is exactly what we have here, a numerator. So what you do is you write each term over that denominator. So you write each term over that denominator. Term over the denominator. Hope you can read that yellow over there. And that's exactly what we're going to do in this case. We're going to take each of these terms and we're going to write them over that denominator. So what we'll get, we still write the dx, very important. You'll lose a mark if your equal sign is not in the right place. And all I'm going to do now is I'm going to take each of these terms over here and I'm going to write them over that single denominator. And this is a rule, so that when you see that you have multiple terms in the numerator, this is what you do. This is how you approach the question. So I'm going to get x to the power of 3 over 2, and that's going to be over 2x to the half, to x to the power of a half. And then the second term is going to be, I keep the sign on the top, which is a plus, and I have, remember, it was a 3x to the 1 over 3 on the top, 3x to the power of 1 over 3 on the top, and on the bottom I still have 2x to the half. And all I'm doing at the moment is I'm trying to get this question into a slightly more differentiable form, something that I can apply these rules of differentiation on. Because when you look at the question as it was given, we don't have tools, we're not taught these tools in matric maths to deal with a question as it currently stands. So all I'm doing is I'm rewriting it in such a way that I can then apply these rules that I know. So Back down here, I'm almost done, but I can now simplify in terms of the x's because I'm going to get things cancelling over here. And I'm still going to be writing my big dx. Right, now remember your laws of exponents. They say that, notice how I write the 1/2 on its own, and the laws of exponents say that you'll have a single x on the top. I'm going to take this 3/2 and I'm going to minus the half up there, because that's the laws of exponents. And again, I've written the half separately because that's going to make my life easier in the next step. So if I can do things to make my life easier, I'm going to do them, and I'll show you what I mean in the next step. Over here I have plus 3/2, and again I'm going to write that completely separate of the x so that it appears to be a coefficient, because it just makes the next step easier. And then I have this x over here, and I have a 1/3, and I apply the same law. I simply subtract the 1/2. Right, next thing. Let's see what happens here. I'm going to close off my square bracket, and let's keep going with this guy. And I get a big dx. I'm just going to speed up this little process over here. I get a 1/2, and 3/2 minus 2/2 is x to the, I hope you can all see that, it's just an x to the 1. 3 minus 1 is 2/2 is 1, and plus, and this you can plug into your calculator if you're not so confident with these fractions. You can just take a calculator and go 1/3 minus 1/2, and that'll give you an answer, and the answer is -1/6. LCD of 6, 2 minus 3 is -1/6 on the top, x to the power of -6. Let's not leave the x out. Right, next thing we do is we are now ready to apply our derivative. And notice that at this stage, we don't write dx anymore. So it's just going to equal no dx, and we can now apply the laws of derivative, because this thing is read as the derivative of that. So up until now, in English, if you had to describe what we've done, we would have said something like this. We'd say the derivative of this expression is equal to the derivative of this expression, which is the same expression but simplified, which is equal to the derivative of this expression, because I haven't yet done the differentiation, I've only rewritten it in a slightly better way, which is equal to the derivative of this expression, which is equal to the above expression, even simpler, which is equal to the derivative of that. And now finally, I'm not going to say it's equal to the derivative anymore, because I'm now going to apply the derivative on this expression. So my final step is differentiation laws. Right, so if you just have an x to the power of 1, remember you just take your coefficient. So the first answer is 1/2. And the second answer is plus 3/2, and it's much easier when the 3/2 is separate of the x, because you can see that the coefficient of x in this case is 3/2. And I'm going to multiply it by -1/6. Right? And if you can do that in your head, that's also okay. And then remember what happens to the exponent. You end up subtracting 1 from the exponent. And that again you can actually do on your calculator. You can just take this fraction over here, subtract 1, and you'll get your final answer. And it's 6/6, which is -1 minus 7 gives us -1 minus 6, which gives us -7/6. And again equals, and I'm just going to simplify this thing, and we get -3/12, which in actual fact is -1/4. And the x is currently at the top, to the -7 on 6, like we've said. And sometimes they might ask you in the question to rewrite things with positive exponents only. So there's a final step that you would need to do in this case, and that is to take what you've got, and over here you'll notice this negative exponent, and we're just going to convert that to a positive exponent. So I'll bring this x down to the bottom, and now at the bottom I'll have the 4 and the x to the power of +7/6. And that would be a final answer. Okay, so a couple of tricks there. Change all square root signs to exponents. And again, the second thing that we used in this case was if you have more than one term on the denominator, if you have more than one term on the numerator and a single term on the denominator, then you write each term on the numerator along with that bottom term. And just remember notation.